All right, welcome to lesson 10.4. Today we're going to talk about factoring trinomials when a isn't 1. So when you factored trinomials before, the coefficient of x squared was always a 1. And those are a little bit easier to do because you just have to focus on factors of c that add up to b, and then your signs. So today we're going to throw in a different element, and that is a is not going to be 1. So there's lots of ways to do this. There's a guess and check method. There's something called the AC method. There's something called the grouping method. There's something I learned from some of my students that were from Korea. I coined it the Korean method, but they learned it in Kumon. So there's a lot of ways to approach this. This is just one way to do it. And then maybe next year with Mr. Stern, or potentially in 9th grade, you'll maybe learn a different way to do it. And then you can decide which way is more efficient for you. So you need the next notes, 10.4. And I'm just going to set it up here really fast. Notice at the top of the screen, I give it's always trinomials that are in standard form. So ax squared plus by plus c. And this time, a is going to have a number. So we're also at the end of this lesson going to solve equations once we factored them. So just like we did with the vertical motion model. Okay, so I'm calling this factor by grouping. It's also called factoring using the AC method. Sorry, I had the wrong thing open. It's also called factor using the AC method. So whatever you want to call it, doesn't really matter. Basically what we're going to do is I have all the steps here on the side. I have to change one of them because I changed my mind about how to represent something, but I had already sent the notes out. So always, always, always when you're factoring, step one is to look for a GCF. Half the time there'll be one, the other half there's not. Sometimes you can't factor unless you pull out the GCF, so start there. If there is one, pull it out and then make sure you bring it down in your answer. So if I look here, 2x squared, 7x, and 3, none of those have a GCF, so I don't have to worry about step one. So again, it's like a 50-50 chance. Okay, step two. This is why it's called the AC method. I'm going to multiply my A times my C. So notice the thing, the coefficient of x squared is A. Sorry for my cat. The coefficient of x is my B, and the coefficient, and the constant is my C. Okay, we don't care about signs at all right now because we're going to use the same rules as the last lesson. So in this problem, my A is 2, my C is 3. I'm going to multiply them together, and 2 times 3 gives me 6. Okay, so in the last lesson, we found factors of C that make B. This time, we're finding factors of AC that make B, because A times C is AC, hence the AC method. Okay, so factors of 6 are 1 and 6, 2 and 3. Okay, so I'm looking again for factors of AC that give me my B. So that part isn't any different. Okay, 1 and 6 make 7, 1 and 6 make either 5 and 7, and 2 and 3 make either 5 and 1. I need a 7, so I'm going to set it up as, I'm going to use the 1 and the 6. Okay, now here's where it gets different. We're going to split the middle term up. This negative 7x is I'm going to use these two things that I circled over here on the right to represent negative 7x in a different way. So I get I'm going to color code this. My 2x squared stays 2x squared. My plus 3 stays plus 3. This negative 7x in the middle is going to be split into negative x and negative 6x. Because if you combine those, negative 1x and negative 6x, you get negative 7x. So all I did was I just split them up using the factors that I found using AC. So now, here's the part where so that was splitting the middle term, so it's written as the sum of your factors. So split your middle term. Okay, now here's where I'm going to change. Step 5, it says draw something around the first two terms. I didn't like how I was doing that before, so we're going to change that to underline. So we're going to say underline the first two terms and the last two terms. Okay, separately. Okay, and don't worry about add a blank. All right, so I'm going to underline this 2x squared minus x, and then I'm going to underline this negative 6x plus 3. Okay, so now here's what I'm going to do. I'm going to pull out a GCF again, but I'm going to look at each pair separately. So we're going to pull a GCF from each set. Okay, so I was going to have you put it in the parentheses, but we're not going to do that because then it looks like multiplying. So the GCF between 2x squared and x is x. So if I pull out an x, what I'm left with is 2x minus 1. Okay. Now, when I pull out a GCF in the second set, it's that what's left in the parentheses has to match. So I need to pull out something so that what's left in here is a 2x minus 1. Now here's where it gets a little bit confusing. This is a plus sign right here. So right now, let me change this. This is a plus sign. This is a minus sign. So in order to change the sign, it means my GCF has to be negative. So that means that I'm going to pull out a negative 3. That's the only thing that matches. So they both have a GCF of 3, but I'm going to pull out a negative 3 so that when I divide negative 6x by negative 3, I get my positive 2x. And when I divide 3 by negative 3, that's where I get my negative 1. Okay. If it's helpful, earlier when we talked about GCF, we put the x under here and we put the x under here. So maybe that's helpful to write that. Okay, so now what I'm going to do is, this is just a representation of the distributive property. I'm basically saying that x is being multiplied by 2x minus 1 and negative 3 is being multiplied by 2x minus 1. Therefore, I can rewrite it to say it's the product of the two binomials x minus 3 times 2x minus 1. So, I wrote my final answer as the product of two binomials. And the reason why I rewrote it like that is because if I was to turn around and do FOIL, which we learned in the last unit, I would do x times 2x minus 1, which is right here. Then I would do x times negative 1, which is this right here. Then I would take the negative 3 times the 2x, which is this right here. And then I would take the negative 3 times the 1, which is this right here. So I recommend that you check that. So I'm going to multiply it back out, make sure it checks. What's super cool about this unit is you can multiply everything back out, which is what the last unit was about. And if it matches what you started with, you did it right. So x times 2x is 2x squared. X times negative 1 is negative x. Negative 3 times 2x is negative 6x. And negative 3 times negative 1 is a positive 3. Everything matches, and my middle term is negative 7x. Therefore, I can get rid of all these parentheses. This is my factored answer. All right, so don't worry if you're like, what just happened? Okay, we'll do a couple and then we'll look at how you use this to solve. Okay, so next example, follow the steps. That's what I set them up for, okay? Step 8 is obviously optional, but again, if you want to turn in a test that's 100% correct, I would recommend step 8. So AC method, multiply A times C. 4 times 9 gives me 36. Factors of 36 are 1 and 36, 2 and 18, 3 and 12, and 4 and 9. Okay, so notice I don't stop. I know that I'm trying to make 9 and 3 and 12 are going to give me 9, but I didn't stop because sometimes, like we learned in the last lesson, there's two options, but only one works because of the signs. So let's check. My signs need to be different because C is negative and the bigger one needs to be positive, and 12 minus 3 does make 9. So I'm going to go with 12 and 3. Okay, so I set it up to be 4a squared, and then remember I've got my minus 9, and I'm just color coding this so you can kind of see what I did. I need my two middle terms to add up to positive 9a, so I'm going to write plus 12a minus 3a. Okay, you might ask, does it matter if I would have put the negative 3a first and the 12a second? It doesn't. Later, when you get into more complex problems with grouping, it will matter and you might have to rearrange them. But for now, these problems, every time there'll be a GCF, so it will work. Okay, if not, then I'll eat my words because I said the wrong thing. Okay, but I'm pretty sure it will work either way. Okay, I'm going to underline each set so I can see them clearly. I'm going to pull the GCF out of the first term, or the first set, and the GCF is going to be a 4a. So I'm going to write it this time because I think that's nicer. I get a 4a. What's left is a plus 3. Okay. Now, again, I need to pull it out so what's in the second parentheses matches, and again, I have a sign change, so that means I got to pull out a negative something. So anytime your sign has to go from a negative to a positive, That means you got to pull out a negative something or a positive to a negative. So what I'm going to pull out here is a -3. So I write in front what I pulled out, and I write what's left. I get a plus 3. All right. So distributive property, I'm going to rewrite as the product of two binomials. I get 4a minus 3 as my first term and a plus 3 as my second term. Okay. Order doesn't matter. I could have put a plus 3 first. I could have put 4a minus 3 second. Okay, it's multiplication, so order doesn't matter. I am, however, going to do step 8, which is to check. So I'm going to multiply it out. 4a times a is 4a squared. 4a times 3 is 12a. Negative 3 times a is negative 3a. Negative 3 times 3 is 9. I check that these two terms make my middle term. They do. And the 4 and the negative 9 match my original problem. So I can say with confidence that this is my final answer. Okay, cool. So I'd like you to try on your own number 1, because if this doesn't make sense, then you should pause and Zoom me and ask me some questions. Okay, so hit pause and try on your own number 1. I'll give you the answer in just a sec. Okay, welcome back. Good job. Hopefully when you were done, you double checked. You know you got the answer right already because you did step 8, okay? But you should have got 2x minus 1 times x plus 7. Okay, Zoom me if you need help. And please use my Zoom, okay? Don't invite me your Zoom, because then if I'm talking to someone, I gotta leave and it's a mess, so come to my Zoom. Okay, cool. So we're gonna look at some more examples. These are a little bit tricky because there's a GCF. So the other 2 examples we didn't have a step 1. These 2 problems do have a step 1. So I'm only going to actually do example 4. I don't think you need to see 2. So I'm going to look at all 3 terms in step 4 and see if there's a GCF. We don't right now know how to factor when a is negative. And notice right here it's negative, and same as example 3. So sometimes the GCF is just a -1. You can't factor when x squared is negative. So sometimes, like here, I would just pull out a -1. And then I would go through and do this problem. Okay, I'm changing the signs. Then I find factors of 28 that make 12. Okay, but we're on example 4. So I'm going to pull out, every term has a 2 in common, and there's a negative. So I'm going to pull out a -2. So I get -2, parentheses, 5x squared minus 6x plus 1. Okay, now here's the issue. A lot of people pull out a GCF and they don't remember to put it in the end of their answer. So here's what I like to do. I like to draw a little arrow and say, don't forget, no GCF left behind. So that's what you do when the problems are a little bit longer. Okay, now what I'm going to do is the GCF or the AC kind of factoring method, just with what's in the parentheses. Okay, so 5 times 1 is 5, factors of 5 are 1 and 5. Okay, well, that's not too bad. Those are the 2 I'm going to use. So I get 5x squared minus x minus 5x plus 1. I'm going to pull out a GCF. So again, I'm going to do a little color coding here. The GCF here is going to be x. So I'm going to pull out an x. And I get x, parentheses, 5x minus 1. And again, the signs are different. So notice it's already a 5x and a 1. So all I got to pull out is a -1. If I pull out a -1, so I pull out a -1, pull out a -1. Negative 5x divided by -1 is a positive 5x. And 1 divided by -1 is -1. So my final answer, I'm going to go back to the same color, is the -2 that I pulled out in step 1 times x minus 1 times 5x minus 1. All right, 3 negatives make a negative, which my third term is negative. X squared times, so what I could do is I could double check this right here to see that it matches the highlighted part. And then I would multiply it by -2 to see if it matches my original. So I'm not going to show that because I figure you guys can figure that out. But Zoom me if you want to see me do that. Okay, last example is the exact same thing, only this time it's equal to 0. So what they're asking, all squared equations are a parabola. And the parabola looks like this. Before we looked at the vertical motion model, and there's our little guy, and we said, hey, when does the animal leave the ground? When does it land back on the ground. This time, let's say we've got a parabola on the coordinate plane. When we're finding the zeros, and notice this one pointed down because it was negative 16x squared. This one's going to point up because it's positive. Okay, what we're finding when we set it equal to 0 are these points right here. So we're finding where the parabola crosses the x-axis. Those are our zeros or our roots or our solutions. So when it says to solve, that's what we're finding. They're ordered pairs technically, but we just list them as x equals. Okay, so the only thing I have to do different than I did in the other examples is set the equation equal to 0 first. Okay, because they're zeros, it has to equal 0. So problem number 1, the first thing I would do, or this next example, is I'd subtract 10 from both sides. So I get 3w squared plus 13w minus 10 equals 0. Now I'm going to factor this trinomial. Oops, whoa, I didn't mean to erase all that. I was trying to highlight it. Okay, make sure I wrote the right thing. Okay, now I'm going to factor this trinomial the exact same way we've been doing it. Okay, so 3 times 10 is 30. Factors of 30 are 1 and 30, 2 and 15, 3 and 10, 6 and 5. Okay, I broke my rule of going in order on the left. It should have been 5 and 6. Okay, what are those that are going to make 13? Oh, there's 2. Okay, here's where it gets really tricky. Now, C is negative, a negative 10, which means the signs have to be different. The only way to make 13 with 3 and 10 is if you added them together. They have to be the same sign. So that means that 3 and 10 can't work. You've got to use 2 and 15. So be careful because a lot of people will just stop and go right with the 3 and 10. You got to kind of work it out with the signs. Okay, so I got 3w squared. I've got a positive 15w. I've got a negative 2w because 15 minus 2 is 13, minus 10 equals 0. Now I'm going to use my factor by grouping. So I'm going to pull out a GCF from each set. GCF on the first one is a 3w. 3w. So there's my 3w. What's left is w plus 5. Again, I didn't mean for all the examples to have to pull out something negative, but those are the harder ones, so you're welcome. I'm going to pull out a negative 2. Okay, so I get minus 2, and then I get w plus 5. Okay, cool. All of this equals 0. So I'm going to draw a little arrow over here because I'm running out of room. I get 3w minus 2 times w plus 5. I would probably check that to make sure it works before I continue the problem. Again, going to turn in a perfect test. Now we're back to what we looked at in the vertical motion model with the zero product property. If two things multiplied together equals 0, one or both of the things have to equal 0. So let's figure out what the options are. I either get 3w minus 2 equals 0 or w plus 5 equals 0. Then I solve. So add 2 to both sides, 3w equals 2. Divide both sides by 3, w equals 2/3. So that's one solution, or w equals negative 5. That's the second solution. Okay. Shoot, there's something I was going to tell you. Oh, so basically that means that this graph is crossing the x-axis at 2/3, so almost 1, and negative 5. Okay, cool. So I would like you to try on your own number 3. Okay, just really quick. I'll give you the answer in just a sec. And then your homework is green is going to be doing some problems from the book. So remember, it's like you just click on it and it's pictures of a book that I've used in the past. Blue's a worksheet. Blue's pretty challenging in this one because you have to use a little bit of substitution. So you have to, the problems aren't written quite like they were here, and you have to substitute something in and then get your answer. And then when you plug it back in, you got to make sure that you resubstitute it correctly. So hit pause, take a second, solve. What does A equal? What are the two solutions for A in both of these problems? All right, welcome back. The two solutions you should have got are A equals 5/7 or A equals -1. And neither of these situations are a word problem. So unlike vertical motion model, they're both okay. That's the 2 points where the graph crosses the x-axis. But we're not going to cross one off because it's not a real world situation. Okay, cool. I'm here on Zoom if you need help, so let me know. You have one more lesson after this, and that's the end of Compacted 7. So get excited. Okay, see ya.